We're going to have a quick discussion on the changing trends in HPC. We are not going to focus particularly on HPC. I think we're all here for the benefit of the larger ARM community and the ecosystem. So we will have the discussion on how the compute in general is changing, where things are going, what the trends are. And we have a very representative panel here today. There's supposed to be a slide somewhere, but I'm just going to do a quick intro. So Sada-san, we just heard from him. He's from RIKEN. He is the deputy director of the PostK project. Mark Albunton, you know, he's from ARM, and he's the VP of open source there. Then we have, what's your last name? I'm sorry. Yes. Yes, so we have you here from the HPC SIG group at Linaro. Sorry about that. And also we have Jacob Smith, who is the CMO from Packet, one of the very interesting cloud providers. So we'll talk a little bit about that. So with that, what we don't have going for us today is we don't have a lot of time. It's a pretty tight schedule for a panel with 4 panelists, but I didn't want to drop the opportunity to hear from different points of view on the topic. And I think what we're going to do is we're going to hold questions to the end. If there is some opportunity to ask questions towards the end, we will use that while they're resetting the auditorium here for the keynote or whatever they need to do, right? So with that in mind, I think we all heard that things have been changing to the better in a way that we are now in the process of implementing Arch64 in a variety of segments. We understand that the trends have changed in the past 3 to 5 years. We also have seen the impact that kind of the demise of the Moore's Law have had on the industry. And what I wanted to talk about here today, and probably start with Mark, being from ARM, being also focused on the open source, and ask him a question about, in general, the Arch64 architecture, and how does that there are probably, you were part of many interesting moments that have happened in the past. We all have. I've been at it for about 6.5 years. There are people here in the audience. I see some familiar faces. They were here even before that. But can you speak to the couple of these moments and where we are in that journey today, and what is the role of the open source in that? Yeah. You can sit, you can walk, whatever makes you more comfortable.
I fancy walking around. I don't like sitting when I'm talking to a group of people. So
perfect.
Yeah. So I guess the journey into the infrastructure enterprise space started probably about 10 years ago, and it's groups like Linaro that have been a key part in porting the ARM architecture into a world that it wasn't necessarily part of. And I think in my earlier career, I was part of the mobile segment, working at companies like Nokia for a long period of time. But actually getting the ARM architecture out of the mobile space and adopting standards that weren't necessarily designed with ARM in mind, like ACPI, UEFI, has been a key thing that we've done. And it's been part of the journey. But actually, now I would say that part's done, right? The porting phase is complete. And we're now at the point where there are large-scale deployments. There are systems that you can readily buy off the shelf that have all of the characteristics that you would expect from modern data center technologies. And a variety of vendors building things in all different shapes and sizes to match your performance or cost points. So we're now at the point where we are ready for prime time in the data center. And you're starting to see large-scale deployments. We've got a cloud provider on the stage with us. We've got AWS here at Connect as well. And you'll have seen there the AWS A1 instance be announced last year, early this year. So we're really at that point where open source has kind of enabled this new marketplace, this new ecosystem for the ARM architecture, moving us, outside of the traditional mobile space that we were in. Okay.
That sounds great. So you just spoke to a couple of things that kind of caught my attention. We passed the enablement phase. I think we all agree here. I mean, I'm from Red Hat. If I didn't introduce myself, I probably should have. Some of you don't know me. But anyway, I'm Jan Fischer from Red Hat, and I have had multiple roles related to the ecosystem right now. But what you mentioned and what stuck with me just now is the fact that you think we're kind of over the hump, right? So there is now work proactively going on in the community and actually at Linaro in enabling the software ecosystem and kind of ramping up the developer and enterprise experience, right? So I think Raphael can talk about that a little bit. Since you're driving the work in the actual HPC SIG, can you maybe highlight what is it that you're actually doing and which parts of the stack you think are being optimized today? And as you go through this, there is an angle that I think is ever present. We are doing this in the community. We are doing this in the upstream way, right? So what are the impacts of the work that's being done here, in your opinion, has on the overall server standardization, not just on this architecture?
Yeah, so first challenges from HPC SIG group were related to architecture, like how servers had its firmware working or not, if PXE was working. So initial work was kind of enabling all the machines to be provisioned and to make sure that the software was running. And at the same time, an initial work was started against compiler optimizations, so to make sure that GCC and LLVM supported the architecture. If you take like important HPC libraries like BLAS, for example, BLAS had like some optimizations made for ThunderX2 CPU in the beginning. So, but it was kind of hard for us to plan just because we were kind of enabling everything. So right now we have a fully functional lab. We're looking forward to have SVE capable machines now to help more upstream. There are two types of work going on right now. We have LLVM optimization, which we have a presentation today made by our members, engineers like Fujitsu. They're going to present some of their work, incredible work on LLVM optimization, and also a future SVE enablement for upstream, which is really important for, just like showed in previous presentation. And there are some challenges going on upstream, as you know. So ARM has upstreamed some of the LLVM SVE code that there is a discussion going on right now. This is the part where Linaro can help, like bringing all the members to discuss. I'll give an example. So for example, there is an ongoing discussion if fixed length or variable length should matter for the SSVE optimizations. And the discussion for HPC, we don't care too much just because we're going to compile our code. And if it's going to be optimized for all our machines because all our machines are the same, then it's okay for us, you know. But if we're talking about SVE like for I don't know, smaller devices, then having variable length optimization might be good. So this is the type of upstream discussion going on right now. And to help the ecosystem, what we are doing now is we are making sure that our lab can have multiple labs inside. So we are virtualizing everything. QEMU started supporting SVE emulated. So it's like we could work, but it's not as good as having the KVM enabled for SVE, which just happened last week. We are virtualizing our lab, having InfiniBand, using SRIOV and multiple KVM guests, so we can run functional tests. That's our next move, to get like all the HPC packets from OpenHPC and make sure that all functional tests run because it's virtual, so we make sure that the functionality is there. And we're going to help other vendors as well, because if we find regressions, it's not only ARM regressions. We can find like RDMA regression for libRDMA or libMellanox regression for Mellanox libraries as well. And the future step for this, right after, instead of just functional tests, performance regressions test. So is there a deviation in between like the previous test and this one? Did someone break an optimization that was done upstream? And this is where we're heading at. I think that's kind of what we're seeking right now.
I think it's great, and you brought up OpenHPC, so that's one of the examples of how the upstream or community collaboration can help not just one architecture, but expand the applicable results or improvements or optimizations to other platforms. And through collaboration, you can actually get more eyes on your code, on your platform. So that's great. One other thing that you mentioned, and I think that's kind of goes along with what Sato-san was saying at Riken, is the alignment between the vendors and the community, and also the optimizations that are being put in place right now. They're maybe beneficial for a certain set of or subset of features, but in general, kind of looking at a bigger picture, what are the effects of that? So, Sato-san, a question for you on that is, so Riken is obviously at the heart of the hyperscale race, right? And or exascale, I shouldn't say hyperscale, exascale. We hope that you will break the top 5 or whatever when the post-scale launches. So Raphael described a set of optimizations. You had some slides there. You also had, what caught my attention, you also had one of your KPIs were ease of use and variety of workloads being supported. So that's apparently is very important to you. So the question is, how do you see the role of open source and this open collaboration helping your project specifically, and enabling the architecture of which PostK would be one of the largest installation at the time?
Okay. So first of all, I'd like to say why we choose the ARM. So, and that is, of course, we are happy to choose the ARM architectures. So, but at the moment we started the project, so nobody is interested in ARM architectures for HPC. So, but as I said in the beginning of my talk, now many people is interested in HPC, ARM for HPC. So, but the reason at the beginning of project is that we only have alternative, only just choices to choose the ARM. So far, the current computer instruction set is the Spark, and the Spark is almost dead. And we cannot choose the Intel, we cannot choose the IBM. So the only solution we have is the ARM. But missing pieces for the ARM architecture is that the SIMD. So I think SVE is very important for the HPC. So, but looking at the current situation, the only the processors which is going to support the SVE is our processor. But in the meantime, the Cavium and another processor for the ARM processor for the high performance is going to have the SVE, right? So, and still, we think the SVE is very important, and especially is the compiler technologies for vectorizing is to make use of the SVE more efficiently. So to increase to make the more effective to open source communities for the HPC is one of the key is how to support SVE. So currently, we are using the ARM compiler for the SVE, so support it, and not open and physics compiler. So it's a many difference. So and I would say for the ARM, still the LLVM for SVE is not open yet. So I'd like to ask how to open the LLVM for the SVE from the ARM compiler team. So I think this is the very important issues to make the open source communities more effectively, right? So that is my comment.
Okay, so I guess what you were saying is that SVE was developed as a aid to supercomputing to augment the architecture, but because of the industry-wide collaboration or ecosystem-wide collaboration, SVE is becoming a thing of its own, and it will enable other implementations in the future. And because of the model that ARM has, and because of the number of vendors participating in the ecosystem, this instruction set would actually benefit a variety of companies or a variety of use cases. And that's hopefully will be true. I mean, that's a fair request to ARM to look into doing that. In the meantime, I think you're building a very homogeneous computer. It's and a large one at that. What I wanted to connect here, or the way I'm trying to kind of align this in my head, there will be those implementations out there. There will be big machines. They're almost purpose-built, you know, for science, for large problems, and there will be smaller installations, smaller implementations that can take advantage of the features as SVE. So, Jacob, I guess for you, I have an interesting question here. Packet does have a pretty non-standard model on how you engage the developer community, how you engage enterprises looking to start the development on a new platform. You support, by definition, you heterogeneous. You have that heterogeneity, I believe, in every single center that you guys deploy worldwide. So having said that, or with that in mind, what are you doing differently, and what was the mindset? What's happening under the hood when you were enabling this type of environment? And was there a preference to one architecture or the other? How was the how was the initial deployment was set up, and what was happening with that?
Sure. Great. Well, first of all, it's been really fantastic to be involved in the HPC community, really because of Jan bringing me in on a panel here and in a previous conference. And I have to say, it's really mirrors what we see with some of the biggest enterprises and also hyperscalers. Look a lot like HPC in that they sort of design the hardware around the software instead of the software around the hardware, which is a really interesting concept that I guess is tied to scale. When we got started, like Jan mentioned, we're a multi-architecture shop. We provide access to bare metal, but a lot of our customers are looking for scale. And so I guess, Jan, the answer to your question is that we thought really about user-driven needs. What does a user need? And sometimes it's an architecture that's comfortable to us, but oftentimes it's something that can help distinguish them. So certainly on our side as a cloud provider, we're really a channel for the technology that's coming out of silicon makers and other people in the industry who are creating actual IP. And we're helping to deliver it, hopefully with the opinion of the end user. In this case, a supercomputer, but we're seeing enterprises look more and more like building supercomputers when they get to scale of workload, whether it's AI or running 20 billion API calls a day. And so they have that sort of intent, which is really fascinating. A couple lessons we've learned is that you have to think about variety from the beginning. It's very hard to come back and undo it and make something that's naturally inflexible, flexible. You got to think a little bit. I love that you highlighted ease of use and open source in your design. I think designing for a certain amount of a future that you don't know yet is essentially being open to that possibility. And that's kind of the world of open source, too, in the world of software. It's moving so much faster than we can sort of predict that having a sort of, well, tell me what you need approach is, well, certainly our strategy, but I think it's also where we're seeing a lot of the largest companies go, and they're looking to solve the problem versus simply using the tools that are available. That's what's really attractive about the ARM ecosystem, is it's an ecosystem of solutions versus a menu of predetermined SKUs, which is exciting.
Right. Yeah, great. Yeah, I think the HPC has been historically on the forefront of, they've been on the bleeding edge, the early adopters, the first, foot in the door type of deployments and installations. Certainly what we've heard today, and hopefully you guys agree in the audience, is that it's continuous as we shift the paradigm of computing in general to customized but open model type of implementations, right? So you will see people building, large sites or smaller companies which have now the opportunity innovating at that level where they can build a relatively custom implementations, and they can use and choose different cores now, not just from ARM. There is also a variety of other architectures that are available. I think ARM has an advantage of being there for a while and also having this model of working with multiple vendors. But to summarize, I think what we are experiencing right now is a shift in mentality of how the compute will be delivered. And when I say compute, I really mean the combination. I mean, we saw that in Sado-san's presentation. Memory and networking is being brought on SoCs. All the components are really being integrated and sometimes purpose-built, while they all standardized, which allows folks like Red Hat, SUSE, and Canonical bring a unified layer of the operating system to communicate with all of the innovation that's happening at the silicon level. So with that in mind, with 35 seconds over, I can keep on going and talk about that, but I want to see if we can maybe squeeze in a question or two from the audience before we're going to get kicked out of this room. All right, here's a question. Yes, sir.
Yeah, in Kato-san's presentation, there's a keyword about AI. And so far, NVIDIA has been dominating the AI in the cloud. With Postgate, SVE, there's certainly potential to use ARM as an AI accelerator. I just pose a question to the panel, will enable AI on the supercomputer a strategy for this ARM community, and if it is, what will be, how can we get there?
Great question. Who wants to answer that? All right, Mark.
I think there's a presentation from Matt and Nigel Stevens later, which will explain how that goes. Matt, what session is it? 12. But yes. One of the things that's, I'm not going to pre-announce what they're talking about later, but there's some technology based on the work that was described earlier that's being announced for the mainstream, which should mean that that capability is available everywhere.
And in general, AI enablement has become a norm. I mean, the top 2 supercomputers out there right now, they fully loaded with GPUs. They predominantly run AI-focused workloads, at least from what the press has and what we know. I think that is where we're all going. Enhancement and reduction of the floating point, the size of the floating point can get you an inherent speed up in getting to the answer. That is where inference networks will do great, and I think maybe that's what the later presentation is going to talk about. Sado-san, yeah, please.
So I'd like to add 2 points. So one of the things is that instruction set. So I think current SB is can support the deep learning, but I think it will be enhanced in the next version, right? So, and another thing is that I think from standpoint of the supercomputers, so the main application is just for the training of the deep learning. So for the training for the large scale the network, we need a memory bandwidth and high-speed interconnection. So rather than just the performance of the single processes, we need a network bandwidth and all network low latency, and also the memory bandwidth. So.
Great. Any more questions from the audience to the panel? I'm just risking to to be kicked out of the room, but any thoughts on what we heard today? Any reflections? Okay, well, with that, I want to thank our panel. Thank you for being here this morning, and thanks for a very insightful outlook on the future of HPC. And